Hello, we're now going to go over topic 1, stoichiometric relationships. This topic is divided into 3 subtopics. The first subtopic is Introduction to the Particulate Nature of Matter and Chemical Change. The second subtopic is the mole concept, and the third subtopic is reacting masses and volumes. This video will deal with the first subtopic. The words that are highlighted in yellow are important vocabs that IB wants everyone to learn. These vocabs might be tested on your paper 1 as a multiple choice question, or they might be tested on your paper 2. And IB will directly ask you to define certain words. For example, IB might be like, define elements. And then you would have to respond by writing, an element contains atoms of only one type. You don't have to be exact in your definition, but you need to include some keywords when you're defining them. For example, when you're defining the word element, you must include atoms of only one type. This is a very key phrase of the definition, element. Okay. So let's look at some examples of elements. A sodium atom might be an element, and a hydrogen molecule might also be an element. This is an atom, and this is a molecule, but they are both elements. Why? Because they contain only one type of atom, right? In this sodium atom, there is only one type of atom, sodium. Also, in this hydrogen molecule, there's only one type of hydrogen atom. Let's look at the next word, compounds. Atoms of different elements combined in fixed ratios to form compounds, which have different properties from their component elements. So these two phrases that I've circled are some key points that you must include in your definition. So an example of compound would be water, H2O. There are different elements. There are hydrogen and there is oxygen, right? And they're in fixed ratios, 2:1. And they have different properties from their component elements. So water has a completely different property from hydrogen and oxygen, right? Next, mixtures. Mixtures contain more than one element and/or compounds that are not chemically bonded together, so retain their individual properties. An example of a mixture would be seawater. Seawater contains salt dissolved in water. So the salt and water is not chemically bonded together. So the salt retains its individual property and the water also retains its individual property. Okay? This is a mixture. Mixtures can also be divided into 2 types. The first is a homogeneous mixture and the second is a heterogeneous mixture. A homogeneous mixture is a mixture where all the components may be in the same phase. So all the substance that forms a mixture might be in the solid phase or the liquid phase, gas phase, or aqueous phase. On the other hand, a heterogeneous mixture is a mixture where components are in different phases. Okay, let's see the example for the homogeneous mixture, salt water. As I mentioned before, salt water is when salt is dissolved into water, right? So when salt is dissolved in water, they form an aqueous solution. So they will both be in the same phase, the aqueous phase. However, let's look at the example of a heterogeneous mixture. When looking at garden soil, there are different components, different substances that forms garden soil, right? There's soil, there's water, soil or dirt. Water. There's also gas between the dirt and water. So dirt particles would be a solid. Water, liquid, and gas would be gas. So there are different components that are each in different phases. This forms a heterogeneous mixture. As you have learned from your previous science classes, there are 3 states of matter: solid, liquid, and gas. In IB, you need to learn the key differences between the 3 states of matter. Let's look at the first one. Solid. Solids have a fixed volume, fixed shape, they cannot be compressed. The attractive forces between the particles hold the particles in a closed, packed arrangement. And the particles will only vibrate in fixed positions, and they cannot move around. Now let's look at liquid. Liquid also has a fixed volume, but it doesn't have a fixed shape. It takes the shape of the container it occupies, as you can see in the picture above. It cannot be compressed like solids. The forces between the particles are weaker, so not only will they vibrate, but they can rotate and translate. Lastly, gas. Gases doesn't have a fixed volume, it doesn't have a fixed shape. It can be compressed, and the forces between the particles are known to be 0. So, particles are free to vibrate, rotate, translate faster than a liquid. There can be changes in the states of matter. A solid changing into a liquid is known as melting. A liquid changing into a gas would be known as vaporization. A solid turning into a gas directly is known as sublimation. Going the other way, a gas turning into a liquid is known as condensation. A liquid turning into a solid is known as freezing. And a gas directly turning to solid is known as deposition. You need to be familiar with these words. Properties of chemical reactions and equations. Everyone is probably familiar to chemical reactions and equations. So what is the relationship between the two? Chemical equations are a way to express chemical reactions. There are key characteristics of chemical reactions. The first is that new substances will be formed, right? Because in a chemical reaction, reactants form products. So, reactants will react to form something new. The second is that bonds are broken and formed, resulting in an energy change between the system and surroundings. This will be further dealt with in depth in topic 5. But this means that the bonds in the reactants will be broken and they'll be formed to form new products. However, in this process, there will be an energy difference or an energy change. The third is that fixed relationship between the number of particles of reactants and products results in no overall change in mass. This means that nothing is created or destroyed in the chemical reactions. Things are just changed into different forms. Now I'm going to briefly explain how chemical equations are written and how state symbols, coefficients, and molar ratios take part in this. Here you can see 2 chemical equations. The first equation shows the reaction of solid calcium carbonate reacting with aqueous nitric acid to form aqueous calcium nitrate, gaseous carbon dioxide, and liquid water. The state symbols, which are written in the right-hand corner of each substance, show what state the substances are in. What is an aqueous solution? I mentioned this briefly when I was talking about mixtures, but an aqueous solution is a solution in which the solvent is water. Now let's look at the coefficient for each species. The number on the left-hand side of each substance is known to be the coefficient. So right here we can see that the coefficient for nitric acid is 2. But what about the other substances? There's no number on the left-hand side, right? Then we assume that the coefficient is 1. It's just omitted. The coefficients in a balance equation can be used as molar ratios, which can act as the conversion factors to relate the reactants to the products. These conversion factors indicate the ratio of the reactants that will react, but it doesn't show us the exact amount that will react. Okay. It just shows us that 1 mole of calcium carbonate will react with 2 moles of nitric acid to form 1 mole of calcium nitrate, 1 mole of carbon dioxide, and 1 mole of water. Again, this doesn't tell us the exact amount of reactants that have reacted to form the products. It just tells us the ratio. Now let's look at the second equation. Butane reacts with oxygen to form carbon dioxide and water. The state symbol for butane is gas. For oxygen, it's gas. Carbon dioxide, gas, and water, liquid. Let's look at the coefficients. 2, 13, 8, and 10. So we can say that 2 moles of butane reacted with 13 moles of oxygen to form 8 moles of carbon dioxide and 10 moles of water. Now here we're going to learn how to express our chemical equations into ionic equations and further into net ionic equations. I just brought the first equation that we looked at. Because nitric acid and calcium nitrate are in their aqueous state, their solvent is water, right? The ionic compounds or salts can be dissociated into their ions, which means that I can express the species as ions. So nitric acid can be expressed as 2 hydrogen ions and 2 nitrate ions. The calcium nitrate can also be expressed as 1 calcium ion and 2 nitrate ions. If we split each of these aqueous solution substances into their ions, we can actually write down an ionic equation. So this is the ionic equation right here. However, we can see that the nitrate ion right over here pops up in both the reactants and the product. This means that this nitrate ion hasn't gone under any change. It just spectated throughout the entire reaction. So we call the nitrate ion as a spectator ion right here. And we can eliminate the ion because it hasn't participated in the chemical reaction. And if we eliminate these spectator ions, we are left with the final net ionic equation right over here. Now on your own, try to determine the ionic equation and net ionic equation for the second chemical reaction. Going on to balancing equations. This is very important, and IB loves to test everyone on balancing equations. So the key point is this. You want to make the number of different atoms on the reactant side equal to the number of atoms on the product side. So we need to determine the coefficient for each species and make the number of atoms of the reactants equal to the number of atoms of the products. This is a balancing equation problem, and it is from the real IB test. I'll tell you something very important here. If you take out all the IB questions from papers starting from 1999 to 2020, you can see that IB gives out similar problems. They're all different problems, but the way that the content is applied is similar. So it is important to solve as many IB test questions and learn how IB likes to formulate their questions. This is a very typical and easy balancing equation problem. Let's look at the question. When the equation above is balanced, what is the coefficient for oxygen? For these balancing equations, I'll give you a tip. I tend to balance the atom that is not hydrogen and oxygen first. So right here, carbon is not hydrogen or oxygen, so I'm going to balance carbon first. On the reactant, there is 2 carbons. So I'm going to balance the number of carbons by putting a 2 right here. Then I'm going to balance hydrogen. Why would I balance hydrogen first and not oxygen? Because as you can see, I can balance oxygen last because it's on its own. So I'm going to balance hydrogen next. There's 2 hydrogens on the left-hand side and there's 2 hydrogens on the right-hand side. So that's balanced. Now I'm going to balance oxygen. This is going to be very easy to balance because oxygen is on its own right here. There are 2 oxygens on the left-hand side, but there are 5 oxygens on the right-hand side. I need to make the number right over here to be 5. How can I make that 5? If I put a fraction, 5 over 2, right here, then I can make 5 oxygens on the left-hand side. But is this possible? No, every single number needs to be a whole number, right? Then, how can I make this a whole number? If I multiply 2 for each species, then I can make a whole number. Right over here, I said that if there's no number in front of a species, no coefficient, then it's going to be 1, right? So what is 1 times 2? 2. What is 5 over 2 times 2? 5. What is 2 times 2? 4. What is 1 times 2? 2. So the coefficient would be 2, 5, 4, and 2. The question is asking me for the coefficient for oxygen. So the coefficient will be 5. The answer will be D. This is a very typical balancing equation problem. This is the second balancing equation problem. This is a more difficult question than the previous one. I want everyone to stop the video and try to solve this on your own. So stop. Okay. Now I will explain how to solve this question. Copper can react with nitric acid as follows. What is the coefficient for nitric acid when the equation is balanced? So looking at this question, we can see that the coefficient for copper is fixed. So since there's only copper over here on the product, we can fix this as 3. Then, how would we approach this problem? First, I'm going to split this into reactants and products, and I'm going to see how many of each atoms are in each side. So on the reactants, there is 1 hydrogen atom, there is 1 nitrogen atom, and there is 3 oxygen atoms. On the right-hand side, I'm going to look at it as each species, and then I'm going to add it up at the end. So right over here, there is 6 nitrogens, there is 18 oxygens, there is 2 hydrogen atoms and 1 oxygen, there is 1 nitrogen and 1 oxygen. So in a total, there is 7 nitrogens, there are 2 hydrogens, and there is 20 oxygens. Okay. So now we can see that you need to have a minimum, the reactants need to have a minimum of 7 nitrogens, 2 hydrogens, and 20 oxygens to balance it out with the products. However, if I put 4 as the coefficient for nitric acid, would that work? No, because if I put 4 as the coefficients, then there's going to be only 4 nitrogens. But we need a minimum of 7 nitrogens, right? So A can't be the answer. Same as B. We can't put 6 as the coefficient for nitric acid because we need a minimum of 7 nitrogen. Now we're left with C and D. Now I want everyone to approach this question a bit differently from the previous question. I want you to plug in each answer and see which one works, okay? So this won't take long because there's only 2 options, but if we had all of the 4 options open, then I don't recommend this method. Okay. If we plug 8 in, let's see what happens. 3 copper, 8 nitric acid will give us 3 copper nitrate. And I don't know the coefficient for water, and I don't know for nitrogen. So let's see if this works. Right over here, we can see there is 8 hydrogen atoms, 8 nitrogen atoms, and 24 oxygen atoms. Here, we can see that there is 6 nitrogen and 18 oxygen atoms. Okay. I will balance the one that is not oxygen and hydrogen first here as well. Then it's going to be nitrogen, right? There are 8 nitrogens on the reactant. There's 6 over here, so I need to put 2 right here, right? So if I have 2 nitrogens here, there will be a total of 8 nitrogens on both the left and right-hand side. Next, I'm going to balance out hydrogen. There are 8 hydrogens on the left-hand side. There's 2 here, so if I put 4 as the coefficient, there will be a total of 8 hydrogens on both the left and right-hand side. Now, we need to see if all the number of oxygens equal to 24 for the products. Okay. So there's 18 oxygens over here. There is 4 oxygens on the second one, and there is 2 oxygens here. So 2 oxygens here. Does this add up to 24? Yes, it does. 24 oxygens, correct. So we can see that C is going to be our answer. Try plugging in 10 for the coefficient for nitric acid and see if that works. It won't, but try plugging it in. That's it for this video. I will see you in the next one. Thank you.